The Provincial Planning and Development Office play a vital role in governance. The PPDO's mandates are to formulate integrated economic, social, physical, and other development plans and policies for consideration of the local government. The office conducts continuing studies, researches training programs for implementation, and integrate and coordinate sectoral plans and studies undertaken by the different functional groups. In governance, planning is everything. Governmental organizations as well as private agencies use statistics to formulate their development plans and policies. One of the crucial parts of planning is collection of data and statistics. These are tools and aid in the formulation of plans. To make a concrete plan, organizations use the data related to whatever developmental plans the organization is currently formulating. For instance, in the drafting of the Provincial Commodity Investment Plan, data on agricultural production, commodity value chain analysis, annual rainfall, vulnerability and suitability analysis, and other relevant data will be used as basis in identifying strategic locations, marketability of the commodity, food consumption, and needed interventions. Without it, the planning process can't be possible. And one of the tools for statistics is analysis of variance, or ANOVA. What is ANOVA? ANOVA is the one-way analysis of variance. It is used to determine whether there are any statistically significant differences between the means of 3 or more independent groups. In this study, the independent groups we have are the provinces of Region 13, aka Caraga, which are the following: Agusan del Norte, Agusan del Sur, Surigao del Norte, Surigao del Sur, Dinagat Island. The researchers would like to know if there would be significant differences among the means of the provinces regarding rice consumption amongst Caraganans. We got our data from the Provincial Agriculture Office for the food consumption and from the Philippine Statistics Authority website for the population. Data used in this study is from the 2015 census. This is the latest data we can use for this study, since there was no data available for food consumption and population per municipality and city for the past 5 years.
Hi, I'm going to walk you through on how to solve ANOVA using the Excel's data analysis tool, as well as solving ANOVA using manual method. We're going to use the one-way ANOVA formula, and we're going to check our answers using the SPSS tool, which is the statistical package for social sciences. This is the data we're going to use in solving the ANOVA. We have here the provinces: Agusan del Norte, Agusan del Sur, Surigao del Norte, Surigao del Sur, and Dinagat Islands, and their respective municipalities and cities. We also have here the rice consumption and the population. But the data we actually need is this: the rice consumption per person, it's kilogram per person. So how do we get this? This is the formula. Okay. So for example, the people of Buena Vista, rice consumption is this, and the population is this. So we have to convert that. Use the formula: 7,270 tons times 1,000 kilogram per ton divided by the population. So we have there 117.99 and some decimal places kilogram per person. We intend to extend, or we intend to have the decimal places up to 13, so that we'll have an accurate result when we run ANOVA. So these are the data we need to put in our raw table data. For us to start the ANOVA, we have to convert this table into this, where the provinces are here, the independent variable, and the municipalities are here. The kilogram per person are here. So these are the data that we're going to use to get the analysis of variance. But before we start, we have to formulate our hypothesis. The null hypothesis is this. Mu1 is equal to mu2, which is equal to mu3, which is equal to mu4, which is equal to mu5, which means there is no significant differences among the means of the provinces. So the alternative hypothesis is this: at least one difference among the means among the provinces. So using the ANOVA, we're going to either accept the null hypothesis if there is no significant differences, or reject this one if it's proven that there is at least one province that has a significant difference among its neighbors. Also, for the significance level, we're going to use this. The significance level, also denoted as alpha, is the probability of rejecting the null hypothesis when it is true. For example, a significance level of 0.05 indicates a 5% risk of concluding that a difference exists when there is no actual difference. So we're going to use the 0.05 for the significance level. I will discuss to you on how to get the ANOVA using the Excel's data analysis tool. This is like a shortcut. In order for us to do this, we have to have the data. So these are the data we have from the conversion we did earlier. First, we have to go to data, then go to data analysis. So a dialog box will appear. Click on single factor ANOVA, then click on OK. Another dialog box will appear. So for the input range, click on the input range. We have to choose here, all the way down to the last cell with a data in it. So group by, it should be columns. Click on labels in the first row, so that here. Okay, so let me do that one more time. Yeah, you can see it here. Labels in the first row. Alpha, the significance level is this, 0.05. For the output range, we can click on that. Click anywhere near the table so that the ANOVA result will appear on that specific cell. So click on OK. So there you see the single factor ANOVA. All you have to do is to fix the cells with. Okay, so we can see there the summary, the groups, the count, how many components each group, how many municipalities or cities, the sum, the average, the variance. For the ANOVA, we can see there the source of variation, the SS, sum of squares, DF, degree of freedom, MS, mean square, F statistics, the p-value, and the F critical. As we move along with the manual solution, we'll have a better picture on what are those. Right now, we're going to solve ANOVA using the manual method and with this formula. Yes, I know, formula. But you don't have to worry, I'm going to walk you through along the way in solving this ANOVA. So first we have to get the degrees of freedom between, which has a formula of k minus 1, where k is a number of groups, which is the number of provinces. In the Caraga region, we have 5 provinces here. Agusan del Norte, Agusan del Sur, Surigao del Norte, Surigao del Sur, and Dinagat Island. So that is 5. The degrees of freedom within, the formula is n minus k, where n is the number of municipalities and cities, the total number of municipalities and cities, minus the number of groups. So Caraga has a total of 73 municipalities and cities in total. So let's plug it in. So the k is 5 minus 1, so we have there 4. Degrees of freedom between is 4, and degrees of freedom within is 73 minus 5 is equals to 68. So that's it. Degrees of freedom between is 4 and degrees of freedom within is 68. Now we have the degrees of freedom between, which is 4, and degrees of freedom within, which is 68. So the total degree of freedom is 72. We need this data, the 4 and the 68, for us to get the critical or the F critical. The F critical is one of the bases for us to know if we should accept or reject the null hypothesis. So to get the F critical using these degrees of freedom, we need to have this, the table of critical values for the F distribution for use with ANOVA. The 4 will be our numerator and the 68 will be our denominator. So we go here for the 4. This is the 4. Scroll down and look for 68 here. So the F critical value is 2.51. Okay, next we have to get the means of every group. In order for us to have to find the sum of each group and divide it by the components of that group. For example, here in Agusan del Norte, we have to find the sum of this, add this up, and we get this. Then we have to divide this value to the number of components. So for the Agusan del Norte, we have to divide it, this sum, to the number of components, which is 12. Same goes with Agusan del Sur components or cities and municipalities, which is 14. Same goes with Surigao del Norte. Find the sum, divide by the number of components, which is 21. Surigao del Sur, find the sum, divide by 19. Same goes with Dinagat Island, find the sum and divide it by 7. So here we get each mean for every group. For Agusan del Norte, it's 118 and some decimals. Agusan del Sur, Surigao del Norte, Surigao del Sur, and Dinagat Island. Okay, next we have to find the grand mean. So the formula for the grand mean is this. Grand mean is equal to grand total over n, where n is the number of municipalities and cities. Going back to the table, we have to add everything here and divide by the number of n, which is 73. Since we already find the sum of each group, so all we have to do is to add everything and divide by the number of n. So when we add it up, so the grand total is 8,685.20 and some decimal places, divide by the number of components, which is 73. So the grand mean is here. It's 118.9754 and some decimal places. Next we have to find the sum of squares total. Okay, so here's the formula. Sum of squares total is equal to the sum of quantity each component minus the grand mean square. So let me give you the example. This is it actually. So first I did Agusan del Norte. So let me just make it smaller. So for the table, Agusan del Norte here, this is the first entry, this one. I put it here. We have to minus that to the grand mean. Again, the grand mean is grand total, going back to Excel, divided by the number of components, which is 73. So the grand mean again is 118.97. So this is it, the grand mean. That will be constant for this specific formula. Then we have to square it. The next, we have to put the second component or the second municipality. This data here, we have to put it here on the formula, minus the grand mean and then square. So we have to do that for every component here. It's actually tedious if you do it manually or if you write it down, but you know, Excel makes our life easier. So I put it in Excel. So the result is this, the sum of square for every municipality, this one. So actually I did a formula here in Excel. So if you can see there, B3 is this minus the grand mean then I square it here. Then once I press enter, I drag it down, then Excel will do the calculation for you. By the way, in order for us to have the grand mean constant, we have to put this dollar sign. This one, if you can see the dollar sign there, or for the shortcut, click on that, then press F4. Otherwise, the grand mean won't become a constant, then it will drag down to other values. So once we get this, we have to sum it up, find the sum for every sum of square, then find the total sum, which is this. Sum of square total is this, 409.2792, and some decimal places. Okay, the next part is we solve for the sum of squares within. The formula, this is the formula, and it explains like this. The summation of quantity, each component of Agusan del Norte minus the mean of Agusan del Norte squared, plus the summation of quantity, each component of Agusan del Sur minus the mean of Agusan del Sur quantity squared, so on and so forth. So for example, here's an example. This is an eyesore example of the sum of squares within. For Agusan del Norte, the first municipality is this. We have to put it here in the formula, then minus Agusan del Norte's mean. So earlier, we got the Agusan del Norte's mean. Next, we have to sum it up. We have to do this for every Agusan del Norte's component, and the constant for the mean is Agusan del Norte's mean. Using this formula, then we have to add another for Agusan del Sur, this value 115.995, we have to put it here for the formula, minus Agusan del Norte's Agusan del Sur's mean, then square. This is it. So we have to do that for every municipality. So of course, Surigao del Norte, you have to use Surigao del Norte's mean, each of this minus Surigao del Norte's mean, then you have to quantity square, then Surigao del Sur, Dinagat Island. So once you do that, the result is this. Sum of square within, but there's a formula. Again, Excel can make our lives easier, so for the formula is this. B3, go back to the top. This one minus Agusan del Norte's mean, again, which is this. Then we have to square it. Again, to make Agusan del Norte mean a constant, then again, we have to put this dollar sign. Then we have to press enter, then just drag it down to get it, to get everything. Same goes with this. You have to make Agusan del Sur mean constant, so that for every formula, it is constant here. Then we have to sum it up, then find the total sum or the sum of squares within. So this is it, 0.0156 and some decimal places. The next step we're going to do is to find the sum of squares between. Here's the formula. Sum of squares between is equal to sum of squares total minus sum of squares within. We already have the value for the sum of squares total and the sum of squares within. So here it is. Sum of squares total is 409.27922, some decimal places, minus sum of squares within, which is 0.01568, some decimal places, and that is equal to 409.2635 and some decimal places. The next step is we need to get the mean square between. So the mean square between is equal to the sum of square between divided by the degree of freedom between. So earlier we got the degree of freedom between, which is the formula again. Degree of freedom between is k minus 1, which is 5 minus 1, which is equal to 4. Because again, we have 5 provinces minus 1, so the degree of freedom between is 4. And we got the sum of squares between, we minus the sum of square total minus the sum of squares within. So here it is. The sum of square between is this, 409 0.2635 and some decimal places, divided by degrees of freedom between, which is 4. The mean square between is 102.3158848. The next step is we have to find the mean square within. So here's the formula. Mean square within is equal to sum of square within over degree of freedom within. So going back to the table, we already have the sum of square within, and we also have the degree of freedom within. So if we plug in the information to the formula, so we have here the sum of square within, which is equals to 0.01568 and some decimal places, divided by degree of freedom within, which is 68. So we have the mean square within, which is 0.0002300635. We already have the mean square between and the mean square within. So the next step is to get the F statistic, which is this. F statistics is equal to mean square between over mean square within. We already have the mean square between and the mean square within. So all we have to do is to plug it into the formula. So here. So mean square between is 102.3158848 over mean square within, which is 0.000230635. So the F statistics is equals to 443,627.5262. We're now finished in solving ANOVA using the manual method with the use of the formula. So I'm going to do the summary here. Okay, before I forget, I put there the F critical. If you can remember, we get the F critical 2.5. We refer to the table, this one, and we use the degrees of freedom between and within. 4 for between and 68 for within here. So we got the F critical of 2.51. That's it. So I'm going to copy this and paste it to the worksheet where we did the Excel's shortcut method in solving or in getting ANOVA. So if we check here, it's the same. Degrees of freedom between and degrees of freedom within. Sum of square total there. Mean square between, mean square within, the F statistics, and the F critical. So in the table, it's rounded off. In order to know if we have to accept or reject the null hypothesis, we have to refer to this, the F value and the F critical value. So accordingly, the F critical value is a specific value you compare your F value to, or F statistics to. In general, if your calculated F value in a test is larger than your F critical value, you can reject the null hypothesis. So here, the null hypothesis is mu1 is equals to mu2 is equals to mu3 is equals to mu4 is equals to mu5, which means there is no significant difference among the means of the group or the provinces. That's the null hypothesis. But the alternative hypothesis is at least one difference among the means. So based on the calculation we have using the Excel shortcut and the manual method, so the F statistics is greater than the F critical. So we can see there that there is a significant difference among the means, and we have to reject the null hypothesis. One way to check if we are correct in rejecting the null hypothesis is to look for the p-value. When we did the calculation, we did not solve for the p-value, but the Excel's data analysis, there is the p-value, and that's here. It's 2.3995 times 10 to the power of negative 149, which is way smaller than the 0.05 level of significance. A small p-value typically less than or equal to 0.05 indicates a strong evidence against the null hypothesis. So you reject the null hypothesis. So based on the F statistic, which is greater than F critical value, and based on the p-value here, then we reject the null hypothesis. Okay, lastly, I'm going to check if our calculation here is also the same as the calculation if we run the SPSS software. So here is the SPSS software. I'm going to run ANOVA here. So we're checking if we're going to have the same results. Assumption, provinces, then okay. So for the ANOVA result, it's actually the same as what we have in the Excel. So let's check real quick. It's actually similar. The p-value is actually here. It's 0.000, but the p-value is 2.3 times 10 to the negative 149. So it's like 149 zeros before we get the 2. So it's similar. Here it's still similar, robust test of equality of means. So there's significant differences among the means. But for the multiple comparisons, we check here, still 0, 0, 0, but we see here 1, which means Surigao del Norte and Surigao del Sur, there is 1, which is greater than 0.05, which means there is no significant difference between Surigao del Norte and Surigao del Sur. Same goes with Surigao del Norte, Surigao del Sur, Surigao del Norte. However, if you compare Agusan del Norte to other provinces, there is significant differences. So that's how we check the ANOVA using Excel as well as the SPSS tool. Just to clarify, why is it that Surigao del Norte and Surigao del Sur is similar, which means there is no significant difference between Surigao del Norte and Surigao del Sur? It's because of this. If we go back to the data, if we check the data here, Surigao del Norte and Surigao del Sur, they are similar, so no significant difference, and that's based on the test, the comparison. But still, in general, we have to reject the null hypothesis because the null hypothesis says the means amongst the provinces should be equal, but the alternative hypothesis says at least one difference among the means. So based on the calculation, there is at least one difference among the means. So actually, if we check here for the comparison, Agusan del Norte compared to the provinces, there is a significant differences among the means. So that's it.
The researchers conclude that there is significant difference among provinces in rice consumption, with Surigao del Norte having the highest mean of rice consumption per individual and Dinagat Island ranking the lowest. Although Agusan del Sur has the highest population and Agusan del Norte has the highest consumption per province in metric tons, the provinces rank 3rd and 4th in rice consumption per person respectively. Based on the result where the p-value is less than 5% significant level, the researcher rejects the null hypothesis.